Before we do probability calculations, we'll spend a few minutes just getting solid on the underlying key concepts. This is important because even in simple probability problems, there can be some tricks that will stump your intuition. So we'll get these set and then we'll move on to some calculations. Specifically, the concepts we'll be talking about are those of experiment, sample space, and event. We'll start with experiment. So a probabilistic experiment is an occurrence that leads to one of a number of outcomes. Here are some examples. So tossing a coin is an experiment that results in the outcome of either heads or tails. Similarly, tossing two coins could be its own experiment, leading to one of 4 different outcomes, which we'll write later. Throwing a die could lead to an outcome of a 1 through 6 number. Waiting for a train is a more important outcome, where you're interested in the amount of time you have to wait. And finally, selling a fashion good over a short season could be viewed as an experiment in which the outcomes are the number of people who purchase this good. Now, the sample space is associated with each experiment and lists all the possible outcomes of this experiment. So we'll again look at a couple of examples. For tossing a coin, the sample space is very simple. It has 2 outcomes, heads or tails. Tossing 2 coins has a little bit more of a complex sample space because I have to track the 2 different stages. And there are 4 outcomes. The first is 2 heads, followed by heads and tails heads, tails and tails. And each of these outcomes may have a different probability. Also, in our waiting for a train example, this has a sample space, which is a little bit different. This includes all numbers within some range. Let's say for simplicity that you know you'll not wait longer than 30 minutes at the absolute max for your train. This means that your sample space looks like this, where this is shorthand for any number between 0 and 30. So your train could come in 0 minutes or 15.576 or 30 minutes. But this encapsulates all of the possible outcomes, so it's the sample space. Now, an important aspect of the sample space it's important to get it right, and so there are a couple of things to keep in mind. Sample spaces must have outcomes that are mutually exclusive, meaning they don't overlap, and completely exhaustive, meaning that you've taken account for everything that could potentially happen. This may seem pretty simple. Let's just look at a quick example of what could potentially go wrong. Let's say you're looking for the sample space for an experiment where you'd like to select a customer at random from your customer base, and let's say you sell books to college-age people. And for some reason you're interested in the percentage of those people who are students and the percentage who are employed. So if you wanted your sample space, you might try first this. Either I'll pull a student or someone who's employed. And hopefully you'd realize pretty quickly that this is not completely exhaustive. There could be people who aren't students and aren't employed. So perhaps you'd try again to write out the sample space and do something a little more complex like this. Maybe if I draw a customer at random, they'll be a student or not, or they'll be employed or unemployed. However, this is not mutually exclusive. For example, you could have a customer who's a student and employed, meaning they fall into 2 different groups here. And this is a problem when you calculate probabilities. And so finally, hopefully you'd arrive at something like this, which is shorthand for student employed or non-student employed, student unemployed, and non-student unemployed. And if you think carefully about this, every possible person in your customer base falls into one and exactly one of these different outcomes. Okay, the last concept we'll talk about is that of an event. And an event is just any subset of the sample space, any combination of outcomes that you care about happening. For example, the event that you toss heads at least once in the experiment where you have 2 coin flips can be written like this. It's just 3 out of the 4 outcomes. Another example could be the event that you wait less than 10 minutes for a train. So this is a subset of the range 0 to 30. It's just the range 0 to 10. Now these are all important concepts for you to understand, and I encourage you, if you get confused in the problems that come or in DMD, to write out the sample space and think about what's really going on underneath.